definition of a parabola is a curve where any of its point is distanced equally from the directrix, fixed straight line, and the focus, a fixed point. There are four important features on a parabola. These are the directrix and focus, which were discussed above, and the axis of symmetry, which is the line that goes through the focus and at right angle to the directrix. The vertex is the point where the parabola makes its sharpest or most significant turn, usually at the middle and is halfway between the focus and directrix.
This is a simple equation which will determine a parabola. The equation being y is equal to 5x squared take away 20x plus 15. With this equation, we are going to find out the 3 points which can determine the curve. You can see that the equation can be divided by 5. After the division, the equation is changed to x squared take away 4x plus 3. Now you just factorize to find out your 2 x points. Now you should have your 2 x points plotted on the graph, and it's time to find your y. We already know what the x coordinate is, as it is always in the middle. The x coordinate is 2. Now we have to substitute it into the equation to figure out the y coordinate. Prime example of a parabola that we have all seen is a swing. So why are swings the shape of a parabola? This might be something that you haven't thought about before, even though you've been on a swing at some point in your life. Basically, the shape of a swing is curved in order for momentum to be generated. I'm sure that it would be hard for you to imagine a swing where the movement is not curved. How does the arc shape of the swing movement generate momentum? Riding a swing is similar to the movement of a pendulum. In both cases, energy is generated in the same way. As the pendulum or swing rises, its kinetic energy transfers to gravitational potential energy, and when it falls, the energy is transferred back to kinetic energy. In simple terms, when the swing is being lifted up, the energy changes from moving energy to energy that can be used if gravity pulls the swing back down again. When all the energy from being lifted up is used, the swing falls down and the energy becomes moving energy again. When people ride on swings, they generate momentum to either start moving the swing or to swing even higher. Since gravity is a factor that moves the swing, it is used to increase the height and speed of the swing action. The rider jumps onto the swing and pulls the swing back in order to start the swing action. After the movement starts at a slow pace, the rider will then slightly lift their body at the end of the arc shape swing. The front end of the arc can be seen that the rider leans forward and throws their head forward while throwing their feet back. This allows the rider to be lifted, which generates gravitational potential energy, ultimately generating more kinetic energy, making the swing go higher up at a faster speed.
Parabolas can be seen everywhere and is commonly used in many places. The common uses of parabolas are in sports such as basketball, soccer, tennis and many more, and swings that are commonly seen in parks. Other uses of parabolas can be seen in flashlights, satellites and catapults. Flashlights use parabola to reflect the light into a certain direction. The parabola can be seen in the reflectors as the light shining onto it will reflect somewhere else. Satellites use radio waves as the radio waves are being reflected from a parabolic disc, giving signals to a receiving end while also sending signals back. Lastly, catapults were commonly used hundreds of years ago to be fought within wars. The general concept of a catapult is that there is a heavy object released on one side of the beam to swing the item that is on the other side of the beam. The item that has been thrown will go in a curved line just like a parabola.